So that's multiplying for you. Let's move on to division. So 14 over 15 divided by 2 over 35. Right? 14/15 is nothing in front of it, nothing negating it. But now I'm dividing by 2. If I ignore that 35, dividing by 2 means over 2, right? I'm multiplying by the reciprocal. That's our definition of division, right? A times 1 over b, or A divided by B, means the same thing. So A times the reciprocal is the same as A divided by the original. And now I'm not seeing that 14 and 35 have common factors. That's irrelevant. Now I'm seeing that 14 and 2 have a common factor. 7 times 2 and 2, that 2 cancels. And when we were multiplying, 15 just stayed 15. It didn't cancel with anything. Now 15 and 35 have that 5 in common. So it can cancel out. So I have 7 and 7 over 3. And of course, that's not our final answer. 49 over 3 is our final answer. Let's try it tossing some variables in there. So instead of 14, let's do 14x squared. Instead of 15, let's do 15yz. Divided by 2 over 35x y squared. Go ahead and see if you can finish that one on your own as a review problem. Right, just like before, we leave the first fraction the same. The second fraction gets flipped. Before we even think about factoring, looking to see what they have in common, we need to have it as a multiplication problem. Now, I can recognize even's going to cancel with even. Oh, what happened to my x squared? There we go. Even's going to cancel with even. 7 times 2. 35 and 15. 5's going to cancel there. Here's my 5. Now, why did I leave x squared as x squared, but I rewrote y squared as y times y? Well, it's because x's aren't canceling, but y does cancel with y, just like 5 cancels with 5. Oh, I forgot to write the 2. There you go. And the 2 cancels just like it did before. So it's 7 times 7 times x squared times another x. So that's 1, 2, 3 x's. I don't have to literally write out all 3. I can start at 2 and then just add 1 more. And the y. And down here 3 and z. And just prettying that up. 49 x cubed y over 3z. Right? Nothing new there. But nothing new in these problems either. Let's say I have 3p minus p squared over p cubed minus 27. P over p squared plus 3p plus 9. before I even try to start factoring, oh, p cancels out, or factors out here. No, no, no. I need to turn this division into multiplication. 3p minus p squared and p cubed minus 27 are unchanged. It's the second one. So p squared plus 3p plus 9 moves up, and the p moves down. Now I can start factoring. So 3p and p squared factor out of p. And I just have a linear binomial here. I'm done. Here, p squared plus 3p plus 9. P squared, that's going to be p and p. 9, see, it's either 1 and 9 or 3 and 3. If it's 3 and 3, that's 3p and 3p, that's 6p. Doesn't work. If it's 1 and 9, 1p and 9p, that's 10p. That doesn't work. This trinomial does not factor. I've got to get rid of those extra parentheses. This just stays p squared plus 3p plus 9. Pretty unsatisfying. Now let's look at my denominator. I'm going to write the p first just because that's easy and I know it cancels. All right, p times this. P times, great, that's going to cancel. Over here, p cubed minus 27. I can't factor out a p. It's not a difference of squares, but this is perfect cube and this is a perfect cube. We kind of skipped past difference of cubes before, but it is in the book and you can recognize this. A cubed minus b cubed does factor. So to get a cubed, it's got to be a times a squared. To get b cubed, it's got to be b times b squared. And to get negative b cubed, it's got to be negative b times positive b squared, right? Otherwise, negative negative will give you positive. So what's going on in the middle here? Well, I'll just tell you. It's plus ab. Right, let's try that. A times a squared, a cubed. A times ab, a squared b. But when we get here, that's going to be a squared b negative. That cancels. Then a b squared. When we get here, negative b squared a. Negative ab squared. That's going to cancel. So I'll get 6 terms, but terms 2 and 3 cancel, terms 4 and 5 cancel. It's just these two left. So here's my factoring. P cubed minus 27. There's p minus 3. And p squared. This is minus, this is going to be plus. 3p. This is minus, this is going to be plus. 3 squared, which is 9. P cubed plus 3p squared plus 9p minus 3p squared cancels, minus 9p cancels, minus 27. So that's what we started with. This green product is equal to this. Now, what do you notice? P's cancel. P squared plus 3p plus 9, p squared plus 3p plus 9. We're done, right? 3 minus p over p minus 3. Hang on. Something... Can't we do anything here? We've got p's, we've got 3's. No, we can't do something. 3 minus p has a positive 3 and a negative p. Here I have the opposite, positive p, negative 3. Let's factor out a sign. The opposite of negative 3 is positive 3. The opposite of positive p is negative p, right? If I distribute this negative, I'll get my red numerator. It's annoying to write -3 plus p. Let's just leave that negative out front. Instead of -3 plus p, let's write that p minus 3. What do you know? P minus 3 over p minus 3. We can put parentheses around it if we want. We just get a negative sign. Well, -1. In other words, if I had multiplied this binomial times this trinomial, gotten that big 6-term thing, and then combined like terms, and distributed this p over here, I would have gotten a polynomial over its opposite. It would reduce to -1. Not every problem reduces so dramatically. To divide polynomials, just like with rational numbers, to divide rational expressions, just like with rational numbers, you get the reciprocal of the second term, right? Dividing of p over p, reciprocal of the second term, factor, cancel common factors, maybe continuing to factor creatively, factor out a -1, maybe that lets you cancel, and sometimes you're left with just a single number. Usually not though.